Imagine a volcanic eruption so powerful that it could wipe out most of the United States and plunge the world into a volcanic winter. That's what could happen if the Yellowstone supervolcano erupted. This massive volcanic system has been dormant for thousands of years, but scientists have recently discovered a disturbing sign that it might be waking up. A mysterious gas that has been locked in the Earth's mantle for billions of years has been detected leaking around the volcano. This gas is indicating that magma is rising to the surface. This is a very alarming sign because this gas is produced by radioactive decay deep inside the Earth, and it should not be escaping unless there is a lot of pressure and heat. How did this gas get there, and why is it escaping now? What does this mean for the future of Yellowstone and the planet? When will the volcano erupt, and what do scientists say about this? Let's find out. Yellowstone National Park in Wyoming is home to the Yellowstone Caldera, an active supervolcano. The volcano has the power to produce an eruption of magnitude 8, which is strong enough to wipe out any form of life near it, including neighboring states. The Yellowstone Volcano Observatory was established to monitor the supervolcano's activity and to track any changes. The observatory is solely responsible for all matters concerning the supervolcano's activity, and it's in charge of detecting rare gases that could indicate an impending eruption. One of these rare gases is ancient helium, which hasn't been seen for a long time, and is not a good sign. Yellowstone National Park is also famous for its hot springs, geysers, and other hydrothermal features, all of which emit various gases from deep within the Earth. Neon, argon, carbon dioxide, steam, methane, and helium are examples of these gases. However, helium gas emissions are not abundant when compared to others. According to U.S. Geological Survey scientists, the majority of the helium gas detected in the park originates deep within the rocks, where it has been trapped for hundreds of millions of years before it was discovered. Helium is the second most abundant element in the universe, and it can be found on Earth in two forms, helium-4 and helium-3. The helium-4 is produced by the radioactive decay of heavy elements, like uranium. Helium-3, on the other hand, has 2 protons and 1 neutron. It is mostly a relic of the material that formed the planet, and scientists can use its ratio to helium-4 to determine the source of any helium they come across. For the past 10 years, scientists have been collecting gas samples from the Yellowstone region and analyzed the isotopic composition of helium, carbon dioxide, and other gases in those samples. Scientists discovered that the amount of helium-4 emitted by Yellowstone is greater than what they would have expected and find elsewhere based on their research and analysis. According to calculations made by scientists and researchers, Yellowstone's helium-4 is likely to be hundreds of millions, if not billions of years old. The high concentration of helium-4 in Yellowstone is thought to be derived from rocks within a very ancient crust, known to be buried nearby. This very old pocket of crust, known as the Archean Aeon, was formed over 2.5 billion years ago and contains uranium and other radioactive materials that have been gradually decaying, allowing high enough concentrations of helium-4 to accumulate underground. The scientists hypothesized that the Yellowstone hotspot cut through these ancient rocks around 2 million years ago, releasing the helium-4 stored there along with helium-3 brought up from the mantle. Helium can be found in 2 places, the mantle and the crust. These 2 sources of helium, however, have several varieties. The light isotope, helium-3, dominates mantle-derived primordial helium, while elemental decay in the crust produces the heavier isotope, helium-4, also known as an alpha particle. When we discuss the ratios, we typically compare them to the helium-3 and helium-4 ratio in the atmosphere, known as Ra, which is approximately 0.1384. So if helium ratios are reported as a multiple of Ra, mantle sources would be around 16 Ra, and crustal sources would be 1 to 3 Ra. 2 recent studies investigated helium emissions in active volcanoes. The study first looked at events leading up to El Hierro's eruption on October 12, 2011, in the Canary Islands. Researchers investigated the relationship between helium emissions measured in soils across the island and helium-3 and helium-4 in water from an island well in Geology. They discovered that as earthquakes increased in late summer and early fall, so did the helium emissions across the island, increasing from 9 kilograms per day to more than 24 kilograms per day just before eruption. Along with that, the helium increased from 2 to 3 Ra to more than 8 Ra. According to the research, the earthquakes helped create fractures for the helium to escape as the magma rose and degassed beneath the island, much like a natural fracking process. The crustal helium signature low Ra was, however, overwhelmed by the magma's mantle helium signature higher Ra. As a result, the closer the magma got to the surface, the more helium was released, and the helium became higher. Helium emissions decreased after the eruption as seismicity decreased. When seismicity increased again later, helium emissions increased again, but the helium-3 and helium-4 ratio did not. Instead, it stayed below 5 Ra, indicating that the helium came from the island's crust rather than a mantle-derived magma. The new earthquakes in the island's north created cracks for helium to escape, but the helium wasn't entirely related to new magma. Indeed, helium emissions peaked at 38 kilograms per day well after the initial eruption began, whereas helium-3 and helium-4 peaked concurrently with the eruption. Scientists employ a variety of techniques to monitor volcanic activity and predict potential eruptions. One of these methods involves measuring the amount of helium emitted by the volcano. Helium is a noble gas produced as a byproduct of radioactive elements such as uranium and thorium decay. When magma rises to the volcano's surface, it can carry helium with it, which is then released into the atmosphere. However, simply measuring the amount of helium released is not sufficient to predict when a volcano will erupt. Helium's isotopic composition is also important. Different helium sources have different helium-3 to helium-4 ratios, which can provide information about the gas's origins. In Yellowstone, for example, the highest helium-3 to helium-4 ratios are found in the Caldera's heart, which is relatively close to the assumed mantle hotspot composition. This suggests that the helium was released from deep within the Earth's mantle and is unrelated to any potential volcanic activity. Similarly, scientists have discovered a mismatch between helium emissions and gas composition at El Hierro. This implies that the helium released is not directly related to magma movement, but scientists have discovered more liquid magma beneath Yellowstone than previously thought, causing quite a stir in the scientific world. Previous research suggested that there were two large magma reservoirs beneath Yellowstone, one 3 to 10 miles beneath the surface and the other 12 to 30 miles below ground. They assumed that the shallower reservoir was mostly solid, with only 5 to 15% melted rock. However, after reanalyzing existing seismic data from the past 20 years, with the powerful supercomputer, scientists now believe that the proportion of liquid magma in the shallower reservoir is actually 16 to 20%. While this is still below the 35 to 50% liquid magma threshold that scientists believe will trigger an eruption, it's a significant discovery that adds to our understanding of what lies beneath Yellowstone. Before reaching seismometers on the Earth's surface, seismic waves produced by earthquakes must travel through layers of material within the Earth. Because the waves slow down when they reach molten rock, researchers can use the time it takes them to reach the seismometers to determine how much magma is beneath the ground. The new discovery does not change much about the volcano's risk level, but it does represent a significant advancement in our understanding of what lies beneath Yellowstone. As Carrie Cooper, an Earth and planetary scientist at the University of California, Davis, notes, the Earth hasn't created more liquid magma. Instead, scientists say they now have a more accurate understanding of what was already there. We hope you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.